Okay, so we're looking at question 3b part 2 from the 2014 National 5 Physics paper. It says calculate the specific heat capacity of the block identified in B part 1. Now the block identified in B part 1, which was the previous question, just up here, was X. So I'll just write that in over here. X was the answer in B part 1, and we need to try and find out the specific heat capacity of that block. So let's have a look up and see some of the details about block X. Block X had an initial temperature of 15 and a final temperature of 25. Also, block X has a mass of 1 kilogram. That's important. And finally, the other important piece of information is that block X absorbed 9,000 joules of energy. So with that information, we should be able to determine the specific heat capacity of block X. So let's write down what we know and then what we're trying to find out. So first of all, the heat energy absorbed, EH, was 9,000 joules. The change in temperature was from 15 to 25. That's a change of temperature of 10 degrees Celsius. The mass of the block was 1 kilogram, 1.0 kilograms. And what we're trying to find out is C, the specific heat capacity, the energy required to raise the temperature by 1 degree for 1 kilogram. Now, to be quite honest, if we look at this data itself, we can see that the energy required to raise the 1 kilogram by 10 degrees was 9,000 joules. So you might very quickly deduce that therefore the energy required to raise the temperature of 1 kilogram by 1 degree, not 10, is a tenth of this, which is 900 joules. So that's the answer that we're expecting. And if you were really smart, you might just want to write down the answer 900 joules per kilogram degree C and move on. But what we'll do is we'll put the formula down and we'll do it correctly, just to check. So here we are. EH is equal to MC delta T. That's the way I prefer to write it. I know that the marking, not the marking scheme, the formula book has it as CM delta T. The marking scheme has it as CM delta T as well, but I like to say MC delta T. It seems to roll off the tongue better. Anyway, let's put in the numbers below that. We have 9,000 is equal to 1 times C times 10. So C's here, we want to get C on its own, so we need to divide 9,000 by all of this stuff. And so that would mean 9,000 divided by 1 times 10 is equal to C. And 9,000 divided by 1 times 10 is 9,000 divided by 10, which is 900. So our answer is 900. And the units, of course, joules per kilogram per degrees Celsius. And there we go. Of course, one final point. Using block X is the correct answer. But had you chosen block Y or block Z and done the same working for the values of the change of temperature for block Y or block Z, you would have also got the marks had you got the correct answer for that also.